Okay, thank you very much. Let me start it. So my name is Arun Krishnaswamy, and I'm a director of data science in Workday. And so we are like a SaaS company doing, we have like a ton of products. So instead of going through each one of them, I'll just like directly jump into the topic of the day. So you can see that everyone knows that ML applications and AI applications are mushrooming everywhere. Like every company wants to adapt AI ML features in their products, and there's so much being replaced, a lot of automation, everything is happening, and a lot of these things is driving more and more AI ML features into their products. And so when you go back to several years, 20 plus years, maybe there was this IT revolution, which actually started making a lot of IT applications and stuff, which led to more stringent cybersecurity measures, like, advanced pen testing, there's so many tools developed and stuff like that. I believe we are in a very, very similar phase with AI and ML, and very similar emphasis on improvements to protect ML applications. So we are in a stage where we need to start thinking about it. Like, I think still CISOs and others, they're not like really looking into it that deeply. But I think there's so many adversarial attacks already happening. I think there are a lot of examples of it. I'll show you a couple of them, so to kind of motivate you. And it's coming. It's the next wave of cyber attacks is not going to be on the regular IT applications. It's more towards how do they manipulate and do a lot of other things around AI ML applications. So I'm just going to walk in this presentation. I'm just going to walk you guys through like an overview of the attacks, like some different variations, give some examples and motivation, and discuss some different strategies. It's still a very an area where there's a lot of things needs to be done. My goal was to just introduce this, and then when you guys are thinking about AI ML applications, also start thinking about how do we enable cybersecurity, enable your system to make sure that you're protected from cyber threats, very specifically attacking ML applications. This is not the general application, but it's very specifically to machine learning applications. So I'll just talk about some examples of how this is kind of happens. There's a concept called data poisoning, which probably people are aware, and concepts of training in machine learning. So you can actually poison your training data set with, if you're trying to, predict fishes, you can poison them with images from dog. Or when you're trying to do, dog class, you can actually poison them with images of fishes. And you can actually do it it can be done with such high confidence that you can kind of misclassify the predictions and stuff like that. So it's already there, a lot of literature around it. So, and then the second motivation, which is probably much straightforward and has happened in the recent past, but is kind of attacking the feedback mechanism and stuff like that. So you can see in this, there's a customer rating kind of a thing. So what happened was, the customer rating, someone basically jumped in and gave a, like an example where they gave like a 1-star, like predominantly, just like, it's very similar to your DDoS attack. It's very kind of the same ideas, where you just massively attack the ratings, and then that kind of brings down everything. And obviously, you can imagine there are a lot of recommender systems and stuff which are actually dependent on what ratings the customer is actually giving it to you. And if someone, if a competitor and stuff, they can actually, it's not competition, anyone can actually get in and do this kind of an attacks akin to DDoS, which is very familiar to most people. So this can kind of have a very big impact on the recommendations, and like it can attack the content. It can go a long way in damaging the reputation of a company and so. See, these are like some things which are already happening into the horizon. So I just wanted to kind of just motivate you on, like, give some examples and stuff, right? So let me talk about some kind of an overview, so that it's more like giving the landscape of what kind of attacks are actually possible, and what are the things which is likely out there. So there are overall, I can divide cyber attacks, ML specific cyber attacks, into two types. One is called the extraction attacks, and the other one is called the manipulation attacks. So, and the extraction attack is mostly around confidentiality of the application itself. And the second one, manipulation, is basically attacking the integrity, integrity of the ML model or the ML inference and stuff like that. And broadly, these things can be also happen in three different ways, because when you look at ML applications, there are three main components. You have the input data and stuff, which is used for training and whatnot, or it could be just an input to make an inference, or it could be, and then the second component is the data itself, the data which is used for building the model and stuff. And the third one is just the model itself, like the final model which is there. So you could kind of classify them in these kind of different ways. And so let me go over each and some few examples of what they are, and give you a good sense of what these are. So getting it. So the manipulation attacks, when you look at it, the input manipulation is something more like a manipulation of your ML endpoint. So imagine you have a REST API, which is basically your inference pipeline and inference API for a specific ML application. Then you can actually do a manipulation of the ML model at runtime. So that's what it is. So what typically happens is that you can the attacker can come up with kind of different sets of inputs, and produce a very a different output than what they want. So which basically kind of manipulates the performance of the model itself in real time. And the end user, or the person who actually built the model and stuff, when he takes a look at the data, he thinks that something is really bad with the model and something is happening. He thinks that his model is performing really bad, but he doesn't think that there could be a possibility that bad data input was the reason behind it. And there are a lot of examples here, like a stop sign being classified as a speed limit sign, and there's papers which talks about it. And then spam email being classified as not being spam. So it's kind of, you can do this, and there are many opportunities to do that. And because lack of time, I cannot get into each one of them very deep, but just motivate what it is. And the second one is something I already talked about. It's called the poisoning. It's very famous, like data poisoning and causative. In the sense, this is basically attacking manipulating the attack on the training process. Basically what happens is you basically kind of manipulate or impair the training data, and then which changes the completely system's behavior. So it's basically attacking. The attacker can publish some sort of bogus data, which can influence forecasting models, and so you could do a lot of these things, manipulate the training data, and that actually has deep kind of impact. So the example which already I showed you is the image classification, where you can classify dog and fishes, and you can actually poison the data input, training data, and then you could do a lot of things. And so the third one is the model manipulation itself. It's basically saying that the attacker basically publishes a white box model, and then these models, and that is something very commonly happening nowadays, is people are producing lots and lots of models, Kaggle competition, and so much and so forth. And it's possible that there is a white box models with certain underlying behavior. And what happens is that you can take that model and then say, okay, I want to build stuff on top of it. And what the attacker does is he actually already has some sort of an honeypots and stuff built into the model, which no one is aware. And then if that is being used and it's carried out, and if you don't check it, then the attacker actually knows that someone is using this model. Then he can actually use that trapdoor which he had already created, and he can get in and stuff like that. So that is the model manipulation part of it, right? So these are the different ways a manipulation attack happens. Now going to the extraction kind of an attacks. So again, it's the same model. You could have an input extraction or a data extraction or a model extraction. And then again, what in this case is kind of So differences, depends on the kind of the model and stuff. So in the model inversion part, the model outputs are actually public. Everyone knows what's the output of it, but no one knows what's the input. So what the attacker, so it's basically the attacker kind of plays around with the model and do some extraction and then understands the inner pinnings of the model, which is kind of, once you understand how the model works, what's the inner dimensions and inner features of a model, then he can do a lot of manipulation on it. Like, so extraction is kind of usually the first step to understanding what to do with the manipulation side. But they are usually interchangeable. There's no specific order. So, and model output, then attacker attempts to recover inputs from outputs. That's basically what happens. And one of the classic example where there is a lot of evidence already happening is inferring features of a medical record from the dosage recommended by an ML model. And we can always say healthcare, HIPAA compliant and stuff like that, but more and more we get into the area of recommendation models for medicine and other things. You can run into an issue where the medical records can itself be inferred from the output people are getting, and they can pose as genuine patients and like users of the data, and they can use that to input different data and then understand what's inside the model. And then again, same thing, producing a recognizable image of a face given only the identity. So these things, face recognition models are very common. And then you can actually, that can be also be used to understand what features actually go into do this face recognition. And you can already see that many police departments and public health departments, a lot of departments have started using face recognition and say, hey, we want to use this technology to do things. But there is always a possibility that an adversarial effect on this to kind of manipulate the face recognition, and you will be able to misclassify identifying a person and stuff like that. So it is kind of serious, but again, it is just maybe it's in its infancy, these kind of attacks, but it's totally possible. And the next one is the data extraction. Again, it's just not extracting the features, but they can extract the entire data itself on which it is trained on. And this is kind of an area because there is a lot of deep learning methods which are already built on existing models, because to get to image recognition and other things, it's very difficult to build a deep learning model from scratch. So basically it is built on an existing model, and that data is already public, and there's a lot of things possible not at all that that can be attacked and stuff. And the last one is the model extraction. This is kind of again, it targets a less than fully white box model, and then it's kind of trying to copy its behavior and parameters and stuff. It's more like this is like something which is highly likely to happen, because once it's kind of understanding what your application is doing, and then kind of do a theft of the intellectual property. Because if you go beyond after a point of time, it will be very clear that as more and more AI ML applications, that's going to be the IP, intellectual property of every company. That's going to be the patent side of it. You got to protect it and stuff. But it's just like any kind of intellectual threat. This is going to be big, and imagine you have the most proprietary cutting edge algorithm and stuff, and then some other company or someone, the adversary, actually steals it and then actually starts selling it and things like that. So then you basically lose the edge, and it can be very, very detrimental in a big way. So that's what the attack on model itself, those are the things. I think I've kind of given the rough landscape, and now some different strategies I want to talk about in general is whatever I'm talking about is, the basic stuff, but there is still a lot of work to be done in here. So I'm just kind of going to touch upon, just give an overview of some of the different strategies which every company which is doing AI ML can do it. So one of the biggest things I would suggest is to focus on building pen testing models for machine learning models. Specifically, build a test suite which recognizes deviations of training data and secure ML models. There are startups like CubeLake and others who are actually doing these kind of things. So there are startups which are already motivated by these problems, where they are trying to build like test suites or pen testing tools specifically designed for machine learning models and stuff, like nothing else, So I think that is something many companies should start embracing, like especially enterprise ML and stuff. And then the second thing is use the data sampling part, very sensible. Also, I have a very good understanding of what examples you're using. There is a lot of crowdsourcing, labeling, and other things happening. So you want to kind of monitor them and actually limit their using the number of examples, and or have actually some sort of weightage to the number of examples reported from a specific area and things like that. Because there is so much reliance on external data to kind of feed into your models. You want to be very cautious about like the origin source of the data and how you actually use them in your system, and make sure that is you're very cognizant of the impact of each and every one of the data sets which is used. And then the other one is to have comparisons. This is more like adding a layer of like a feature toggle kind of a thing, in the sense it's kind of compare with previous versions of the model which has been deployed, and I didn't understand deviations and things like that. So you always have like your model and then some sort of a naive model to compare, and then so that you kind of like have this kind of a gatekeeper kind of to make sure that there's nothing bad is happening, and you can actually catch these issues much earlier than what it is. It's more like developing some sort of an alert mechanism within your ML model deployment, and there are many ways to do it. So I'm just saying that you should focus on doing some things too. The other one is to do some sort of a goal sets. I think this is all kind of standards even in machine learning models, but I'm just highlighting it again, doing goal sets, and then making sure that like you can actually simulate these attacks. Say assume in cybersecurity, it's always the story that you always make an assumption that you're always under attack. The assumption is always you're open to attack and stuff like that. That is probably the key, right? And it's always assumed. So the same thing happens here. So you can actually create a lot of goal sets or like data sets and stuff which actually simulate attacks and things like that, so that you can make that as part of even your pen testing capabilities, so that you can actually secure your models against these kind of attacks and prepare it if something like that actually happens. So that is something most of the companies to start focusing on. I think it's the same story with with this talk. I wanted to kind of highlight these things are happening, and I want to, like, the CISOs and others who are attending this conference or anything, kind of start thinking about, if you're not doing it already, start thinking about your AI ML strategy, and make sure you have a cyber attack ML attack strategy as well built into your AI ML strategy. Every single enterprise machine learning or any other company which is focusing on a lot of AI ML applications and features should start looking into these kind of attacks coming your way. And with that, I conclude the session, and I'm not sure like if there are any other questions. So any questions? So yeah, if you have any questions and stuff, please reach out to me. I'm very passionate about this area, so you can let me know if you have any questions and stuff. And I'm happy to talk more on what are the things happening here. Okay. Thank you, guys.